Hi friends, today we are going to see about PSpice simulation tool explanation with some experiments. So first of all, we have to use PSpice simulation tool. So initially we go to program and PSpice designer is there. So from this PSpice designer manager, we will start this workspace window. So whenever you start a first work, automatically you go for menu bar and choose file, new workspace, and it will ask the location. So this software is located in C disk, program file, ORCAD underscore demo, PSpace and workspace is the path. So in this location, we are going to give the project name. So I just give project 2 because already I gave one project. So instead of 1, 2 or 3, whatever you want to give, that name can be given here. Now I change it as project 4. So now the creation will be there. So workspace project 4 is appeared in this workspace window. After that we are going to create a schematic. So in this schematic area only we can able to draw the circuit. So here we choose tools in menu bar and after that click schematic. The schematic window will appear here. So in this schematic area only we are going to draw the circuit. So we know in electronic devices and circuits or electronic communication engineering department we have lot of subjects. So in that subject we can classify analog circuits and digital circuits. So this PSpice simulator can be used for designing our circuit both in analog circuit and digital circuit. So now we are going to see the examples how to simulate and verify our concept with the help of PSpice simulation for digital circuit. So let us start the experiment. Now I am going to take verification of logic gate. So for that I just take all the various kind of logic gates. So this is the what are the different parts we need to take that can be taken from this tool itself. So here we can select 7400. So if we press 7400, these kind of series of logic gates will be appear here in this part area. So what kind of logic gate you want, you can select that. So initially I take AND gate. So 7408 is a AND gate logic gate. So I just select this 7408 and place. So I can place this AND gate here. Next escape and again I move to 7432 OR gate. So 7432 can be selected here and press place button. Now you can place this OR gate here. So again give the escape button. So now we can choose another gate. So the inversion of AND gate is NAND gate. So for this purpose I take 7400 is the NAND gate. So that gate also taken here and place it in a third place. Next 7402 is a NAND gate, NOR gate. That gate is chosen and it is located or placed in a fourth place. So apart from this, we have two more basic logic gates, 7486 XOR gate. So here I can choose 7486 and press place button. Now XOR gate also selected. So finally I will choose NOT gate, that is inverter 7404 and place here. So finally I place that gate. So what are the different basic logic gates are available? So everything is placed in schematic area. So after that we are going to give what kind of input? We are going to give only digital inputs, logic 0 and 1. So for this I just take digi sim. So digi sim is one kind of input, so that can be taken here. So we need to give two input, one is for 0 and another is for 1. So now I take this. Apart from this, we have to show our output. So for that, if underscore out, that operation can be available here. So if underscore out is the one kind of terminals can be used for showing our output in digital form. So each and every gate output should be verified. So for that I take 6 if underscore out terminals and place all these here. So these are the various parts we need to take for simulating this entire 6 basic logic gates. Now we can close this window. After that, here wire. This particular tool is a wire tool. So wherever you want to draw the wire, that can be choose from this, and we can able to draw the wire. So you have to join this wire without any error. Otherwise, we will not get a proper output. So draw correctly. So in case if it is not possible like this, you can remove it, and once again you can draw the lines. Carefully draw these wires. That line is properly appeared and joined with all the input terminals and output terminals. Otherwise, we will not get a proper output. So now the first input is connected with AND gate in first pin, and the second input is connected with AND gate second pin. Similarly, we have to take and wire connect with all other gates. So I take first pin of OR gate is connected with first pin of AND gate. That is the first input. Again, NAND gate is connected with the first input. Again, NOR gate is now connected with the first input. Again, XOR gate is connected with the first input. Apart from this, in an inverter, we need to connect only one input. We can connect with the first input or second input. Now the connection part is over. After that, again, second input should be connected with all other remaining terminals of logic gates. So now the second pin of OR gate is connected with the second input. Again, second pin of NAND gate is connected with second input. And again, NOR gate of second input is connected with. If the connection is not able to made properly, again you have to rework this. Otherwise, you can't able to get output properly. Now all the inputs are connected with gates first and second terminals. Now we move to output side. So each and every output line is connected with output pin of the logic gates. Now the output terminals also connected with the output pin of the each and every logic gates. Now we have to save this. So we just press a save button and we can able to save this. So here semantic1.sch is there. So already I have created that name. So if I want to replace it, I can save again. So do you want to replace it? Press yes. Our file is now saved here. Now we have to rename our digital simulator by variable A, because in this example we are going to give two inputs, so that two variables are renamed as A and B. Similarly, in output we have to set the attribute value as a variable or label name. So first output is AND output. So AND underscore output is named as a terminal of output AND gate. Similarly, we can give R underscore out. Similarly, for third gate, NAND underscore out. And fourth gate, NOR underscore out. Fifth gate, XR underscore out. And last gate, inverter. So NOT underscore out. Now all the different output terminals also renamed by the corresponding output of the each and every individual gates. Now this part is over and we have to give the voltage value, because we are giving our voltage as 0 and 1 for both two inputs. At the same time, our output also either 0 or 1, depends upon the logic function. So for the purpose, we are going to give the voltage or level marker. Voltage level marker can be connected with each and every input side and output side of this lines. So now we are going to do setup analysis. So in this, so before going to the setup analysis, first you have to do this simulation. That is, the A input is selected here, and we are going to assign the clock period for this variable A and variable B. So for period, you have to select, there is two options. The name, attribute name is A, and the frequency and duty cycle is there, and period and time also there. Here I have chosen period and on time. So the entire first cycle, that is the for A input, the total period is I assigned 4 millisecond and on time is 2 millisecond. That means the total period of A input is 4 millisecond, on time 2 millisecond, off time 2 millisecond. So that is applied here, and that will appear in this graph window. Again we move to B and select the stimulus OK, and again the name attribute B is appear here, select period and on time. So we have to differentiate these two inputs. So for that purpose, instead of this 4 millisecond, the total period of the A input 4 millisecond is now replaced by period 2 millisecond and on time is 1 millisecond. That means off time also 2 millisecond. So I just apply and OK it. So now the two inputs are visible here in this graphical window. So now we have to go for setup analysis. So we can choose the setup analysis icon here. Otherwise go to analysis. In this we have a setup. So in this we select this transient. Here we have to choose 1 millisecond. So this 1 millisecond is the output of the corresponding gates. It may be NOT gate or NAND gate, OR gate, etc. That particular on time selection is 1 millisecond, on time and off time. And the final up to which time period this will repeatedly proceeded means 6 millisecond. That means each and every 1 millisecond, one particular clock signal will be produced as output. Totally 6 cycles of signal will be present. So 6 millisecond is the total output for the entire time period. So now I click and OK and close this window. Now we can simulate it. Now the simulation process has taken place. So in this simulation window, we will get a output. So our A is a first input. Initially I gave 1. So for logic 0 and logic 1, because I gave 4 millisecond is the total time period for first input A. So here the logic 0 is appear and logic 1 is appear. Similarly for B input, I choose 2 millisecond is a total time period, and on time is 1 millisecond and off time is 1 millisecond. Apart from this, for remaining all the output of 6 gates, the total time period I assigned as a 6 millisecond. So depends on this 6 millisecond, what kind of input we are going to give. Based on that, it will produce the output. For example, if you take both input A and B equal to now 0, our AND gate will be 0, OR gate also 0, but NAND gate output is now goes high, logic 1. NOR output also goes high, logic 1. XOR output, when both two inputs are same, our output will be 0, so 0 is a result. NOR gate, A is a 0, so output is 1. So in next off time duration, A value is equal to 0, B value is equal to 1. So in this case, A 0, B 1. So if you perform AND operation, A into 0 into 1, your answer is 0. 0 plus 1, 1. This is your OR gate output. Again, NAND gate output is 0 into 1, 0. That 0 is now inverted. Your answer will be 1. So logic high is the NAND gate output. 0 plus 1 is the 1. That output goes 0. So the NOR output becomes 0 here. After that, XOR gate, when the two inputs are in opposite, that is 0 and 1 condition, automatically your output goes to high. And first my input A is equal to 0. So again the NOT gate output becomes 1. And next we move to the next case, 1 0 combination. So A value is equal to 1. B value is equal to 0. So in this case again AND gate is equal to 0. So your output is 1 into 0, 0. OR gate also 1 plus 1, now it is equal to 1. Next NAND gate, 1 into 0, 0. That bar will be 1. So NAND gate output goes logic 1. Next 1 plus 0, 1. That invert answer will be 0. So again in OR gate, our result retain as 0. And XOR operation, opposite input values means output becomes 1. So 1 into 0, 1 XOR 0, our answer is 1. And the last case, NOT gate. So our first input A value now 1. So A bar is equal to 0. So that is appear here. And last case, both input equal to 1 condition. A is equal to 1, B equal to 1. So 1 into 1 and gate 1. 1 plus 1 or gate 1. So 1 into 1, 1. Inverter of this one 0. So NAND gate result becomes 0. And an OR gate answer will be again 0. 1 plus 1, 1. Inverter of this one is 0. So NOR gate output also 0. Both inputs are equal to 1. So XOR output also 1. XOR output also 0, because both inputs are same means output will be 0 for XOR gate. And for last case, A value is equal to 1. So because of this A invert, 1 becomes 0 now. So this is the explanation for each and every logic gates when the two inputs are given like this. 0 0 0 1 1 0 and 1 1 combination. So because we know very well, when you take two inputs, we have a 4 possible combination of input sequences 0 0 0 1 1 0 and 1 1. So based on this sequences, we verify the truth table in descriptive connection while we do the experiment in laboratories. So the same concept can be verified with the help of this ORCAD PSpice tool. So this tool is mainly used for designing purpose, and we can check our result in graphical manner both for analog circuit and also digital circuit. I hope everyone understands this concept clearly. So kindly subscribe my channel and view this videos clearly. If you have any doubt, you can ask me at any time. Thank you all.